In this video, we're going to take a look at factoring hard quadratic trinomials. Hard quadratic trinomials are of the form ax squared plus bx plus c, where a does not equal 1, i.e. this multiplier of the lead term. If it were 1, it would be an easy quadratic trinomial, and you would just find the factors of c, whose sum is b, and move on from there. Okay? So before I go any further, I want to make the point that when asked to factor, you can use any method you want in reality as long as you're coming up with the answer. You have to be able to factor. You got to be able to do it quickly, efficiently, and in an organized fashion. Sometimes, you just have to be able to get the answer for these. Anything short of using computer software or looking it up, to me, is acceptable. You really should know these methods. They're good methods. They're good skills to have. There are 7 steps in this problem, 6 plus checking your answer at the end. Keep in mind, what I've written here in terms of the steps might seem a little bit like a mouthful at times, but doing the problem is actually going to be almost a little easier than actually working through these steps, but they're here for your support, so you kind of have a way to approach memorizing the algorithm and having some type of structure to approach the problem. Okay, I tried to highly color code this so you can follow it along as best as you can, and we'll get started here. I'll review the steps first. Step 1 is compute the product of A and C. Step 2 is replace C with AC and drop the value of A, which indicates I'll be rewriting the problem. Step 3 is find the factors, which I'll call F1 and F2, of AC, whose sum is B. Step 4 is write the product as the quantity x plus f1 times the quantity x plus f2. Step 5 and 6 is where kind of the magic comes in doing this method. Okay, it says divide f1 and f2 by a and simplify the fractions. And then in step 6, it says rewrite the expression using each of the denominators of those fractions as the coefficients of the variables. Now that's more of a mouthful than actually doing it. When I go to do it, you're going to be like, oh, that was pretty easy. Step 7, always a good idea to check your work. Once you factor something, you're writing it as a product. You can check it by just multiplying out your answer. So let's get started here. I've got 3 examples of varying degree, so we'll just work through all of them. First thing I'm going to do in step 1 is compute the product of AC, which is 6 times 5 is 30. And then it says in step 2, replace C with AC and drop the value of A. So I kind of, for now, ignore the value of A. I'm going to rewrite the problem where it says x squared plus 17x plus 30. Now we're going to find the factors F1 and F2 of AC whose sum is B. Well, I'll make a quick factor list of 30, looking for whose sum is 17. 2 and 15 jump out at me. I'm writing the list just to be a little bit academic. You don't even need to write that list that I just wrote out if 2 and 15 jump out at you, okay? Because we do want some efficiency here. I'm just doing it for the sake of the example. So now it says in step 4, write the product of x plus f1 in quantity, which is x plus 2, times the quantity x plus f2, which is x plus 15. It's very much at this point of the problem like an easy quadratic trinomial problem. I think that's what a lot of you guys will like about this method. Now step 5 is where the magic comes in. Well, I threw out that 6 earlier. Well, I'm about to bring it back and divide f1 and f2 by a. So I'm going to take my 2 and 15 and divide them by a, which is 6. It creates 2 fractions. Then we are going to simplify those fractions just by looking at the GCF. The GCF of 2 and 6 is 2. I'll divide by that and get a third. The GCF of 15 and 6 is 3. I'll divide by that and get 5 halves. Okay? Now for the mouthful that's actually quite easy. It says rewrite the expression using each of the denominators of the fractions, which is in this case 3 and 2, as the coefficients of the variables, which means just write them in front of the variables. So this is going to give me the quantity of 3x plus 1 times the quantity 2x plus 5. So I'm able to check this now in step 7 using multiplication. So it's this quick FOIL. 3x times 2x is 6x squared. And then for the outer and inners, I get 3x times 5 is 15x, and 2x is going to be 17x. And then 1 times 5 is 5. So I feel very good about this answer. And we will move on to the next example. Okay? So again, we'll to factor 5x squared plus 18x minus 8. I'm going to compute the product of a and c, which in this case is going to be negative 40. And then I'm going to find the factors f1 and f2 of ac, whose sum is b, which is in this case, oh, excuse me, I have to rewrite the problem first. Sorry about that. Step 2 says drop the a, and we're going to go x squared plus 18x minus 40, right? And then find the factors of AC, whose sum is B. So I'll just make the formal list, but if it jumps out at you, great. 1 and 40, 2 and 20, 4 and 10, 5 and 8. And the middle term goes down the right side when I've got a negative third term. So that's going to give me what? The left factors will be negative. And if you notice there, 20 and negative 2 jump out, so I'm going to write that product as the quantity of x minus 2 times quantity x plus 20. Now for that magic trick of bringing the 5 back into the problem by dividing f1 and f2 by the value of a. So now to simplify these fractions, we get that there's nothing to simplify in the first one. And in the second one, a little different here, we get 20 over 5, which is just going to be 4. I'll write the 1 here just for clarity. And then step 6 says to rewrite the expression using each of the denominators as the coefficient of the variables. Okay, so I'm basically going to swing this 5 up and get, well, let's get this in color a little bit better, 5x minus 2 in quantity times the quantity of, when we swing this 1 up, nothing really happens. So that's going to give us x plus 4. And I can then check this by multiplying it out. We've got 5x times x is 5x squared. And for my middle term, it's going to be gotten by doing 20x minus 2x, which is 18x. And then the last term is negative 2 times 4 is negative 8, making me feel good about this answer. A little different in this example where when you simplified the fraction, you actually got a whole number. You have to realize that the denominator was 1 because that's the coefficient of this variable. It's a little bit different here, but similar in that you have to kind of realize here there was nothing to simplify with that fraction. So that was a little different than the last example too. Okay, so we'll click right along here to the third example. I picked this example because it'll involve our calculator. So 12x squared minus 25x plus 12. Okay, the first thing I'm going to do is compute the product of a and c, which is 144. And then I'm going to replace c with ac and drop this a value for now and get x squared minus 25x plus 144. Okay? So again, I've kind of made an easy quadratic trinomial problem for now, realizing I'm going to go back and use this 12 a little later. So why am I using my calculator? Well, for 144, which is a decently large factor list that you're looking for the factors of 144 whose sum is negative 25, I just want to reiterate that trick where you can go to the y equals button on your calculator and go divide by x, which is essentially what you're doing in the other window, continually dividing by other numbers and seeing if you get decimals or not. And this actually shortens that process by just going to the table, and it's really dividing by everything. Now, you notice here that we're trying to get a negative in the middle. It means both terms will be negative, so I'm just looking for two terms whose sum is negative 25, and that looks like it's going to give me negative 9 and negative 16. So instead of making a long list, just wanted to show that skill on your calculator again. You can use negative 9 and negative 16. So now I'm going to write the product as the quantity of x plus f1, which is a negative, so I'll write minus 9, times the quantity of x plus f2, which is also a negative, so I'll write negative 16, minus 16, more appropriately said. Okay, now divide f1 and f2 by a. So I take my 12, and I'm going to divide both of these terms by 12 and simplify the fractions, which again is going to help me, which will help me with this is understanding GCF very well. The GCF of 9 and 12 is 3, so I divide by 3 and get 3/4. The GCF of 16 and 12 is 4, so I divide by 4 and get 4/3. And then I realize I just need to rewrite the expression using the denominators of the fractions as the coefficients, which is blah, 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 for swing this denominator in front of the variable, which gives me the quantity of 4x minus 3 times the quantity of 3x minus 4. And just for a little clarity, I guess I should have color-coded the signs also because they're part of those values. Okay, just check this with FOIL, which is 4x times 3x is 12x squared. Then we get 4x times negative 4 is negative 16x minus 9x is negative 25x. And negative 3 times negative 4 is positive 12, which means I like this answer, and we shall end that there. So again, I hope you saw that there was a little bit of a mouthful in these steps here where it's like, oh, divide by a, and then rewrite the expressions using the denominators of the fractions as the coefficients. Well, that's just creating fractions, simplifying them, and then swinging up the denominator in front of the variable term. Just be careful when you're simplifying those fractions, you get a whole number, that you realize the denominator is 1, and make sure your writing is clear. So I hope you enjoyed this method. I've only recently learned about it. I can't take credit for it. I didn't invent it. I think it's very clever. Those of you that like it, run with it. Those of you that don't, you're going to have to find another method to do, because you cannot encounter these problems and not be able to factor them. It's your responsibility to become a master factorer. We do this through practice. And paying attention while we're practicing to what methods we like and how to make those part of our repertoire while we master them. Okay, so enjoy. I hope this was helpful.